Okay, so this is day 2 on inverses. First thing, find this slide from yesterday's smartboard, which is the beginning of the second day of inverses. I would recommend that you pause for a moment while you find that. Okay, hopefully everybody is at the first, this page, the one with the golden egg up at the top there. And we're going to be talking about composition of inverses and doing a little bit of solving. All right, so just a reminder of yesterday. We wouldn't have had this yesterday because I was always using numbers that worked out nice. For example, I'd like you to add a page for a second here. And what if we had inverse cosine of root 3 over 2? Well, I hope you remember that I would have you start that by rewriting it as cosine of an angle equals root 3 over 2. But this has got restrictions. In the old days, when you did these so that, students take calc, cosine is positive, and therefore my triangles would have to be here and here. Can't be here, can't be here, because cosine is positive. But now we've got extra restrictions because this is inverse cosine. And so inverse cosine is only allowed in these two, and therefore it can't be here. Now, to label my triangle, cosine is adjacent, root 3 over hypotenuse, 2, and that's the 1, 2, root 3 triangle. And I can tell that this angle right here is the one I want. This thing is screaming out, I want you to give me an angle. And I would then say, oh, the angle that's across from the 1 here is a 30-degree angle, but more professionally, instead of 30, we would say pi over 6. I hope that rings a bell from yesterday on the basic kind. Now, the more advanced kind would have said something like this. Tangent of all that. Well, in that case, since all of this came out to be pi over 6, it's really saying tangent of pi over 6. No need to draw a new triangle. I just look in here and go tangent, TOA, opposite over adjacent. And that's going to be opposite is 1 over adjacent is root 3. So that's a little bit more advanced kind. Well, what's different about this problem is that it's arctan, which is tangent with the little -1. That means inverse tangent. And I can rewrite that. Tangent of theta is equal to 4/5. But wait a minute, 4/5, that's not sides in a triangle that I know. But it's okay. You don't have to know that it's like a 30-60-90 or a 45-45-90. You just go with the process. All students take calc. Where is tangent positive? Here and here. So it can't be here, can't be here. And of these two options, where is tangent allowed? Well, nothing is allowed down here. It's called no man's land. Okay, tangent's only allowed from here to here. And therefore, it's this triangle that really works. And even though those sides aren't nice, TOA opposite over adjacent 4 or 5, this third side can be found. And it's the square root of 4 squared is 16 and 5 squared is 25. 25 and 16, square root of that, square root of 41. So that's square root of 41. And now I can do the cosine of this unknown angle. Notice I never needed the angle. I just needed cosine of it. Cosine is adjacent over hypotenuse. Final answer on this one would be 5 over root 41. Okay? Now, this one's a little more tricky because it's got two separate ones that you need to do. You need to find this one and you need to find that one. And all of a sudden it's sine of something plus something. Now that's right off of your sheet. I'm going to pause for a moment while I pull one of those up. So do you remember on the identity sheet we had sine of something plus something. And it goes like this. Sine of x plus y is sine of x cosine of y plus, notice the same sign as what I started with, cosine of x sine of y. So in the context of this question, once I figure out this angle and this angle, I'm I'm going to need to do all of this to figure out its answer. Okay? So once I have the triangle, though, it's not that bad. I just need the sine of that angle, the first angle, that's this guy, sine in that triangle, cosine in this triangle, cosine of the first triangle, sine of the second triangle. And these triangles, again, I just make a little picture for it and go arc cosine, that's cosine with a little -1 of 2/3. Where is cosine positive? All students take calc. Cosine's positive in these two. So I'm getting rid of those. And I make my picture. Where is inverse cosine even allowed? Only here to here. So that spot's out. Must be here. Cosine is adjacent is 2. Hypotenuse is 3. And yeah, I know that's not one of the triangles we know, but it's okay. I can figure it out. That's square root of 3 squared, which is 9. 2 squared, which is 4. 9 minus 4 is 5. That side is the square root of 5. And now, what is the sine in that triangle? This is my first one. This is like x. The sine in that is opposite over hypotenuse, root 5 over 3. And then I'm going to do the cosine in that triangle. No, cosines of y. So that's this triangle. So I better draw that triangle now. So in that triangle, tangent of some angle is 4/3. Tangent's positive, so all students take calc. Tangent's positive, so can't be here, can't be here. Nothing's allowed here, so I'm going to cross that out. And then my triangle must be here. And tangent, TOA, opposite is 4, over adjacent is 3. This must be square root of some big number. 16 plus 9, 25. Oh, 3, 4, 5 triangle. I should know that one. That one's 5. All right, so now I can do cosine of the y. That's this guy. Cosine of that guy is adjacent over hypotenuse. Adjacent is the 3. The other one's 5, 3/5. See where I'm going here? Now I got to do cosine in this triangle. Cosine's adjacent over hypotenuse, 2/3. Times sine in this triangle. Sine is opposite over hypotenuse, which is 4/5. And one way you can tell you're doing it right is if you have a common denominator. Cool, I do. It's 15ths. So this is 3 root 5 over 15 plus 4 times 2 is 8 over 15. And now I can actually add it all together. 3 root 5 plus 8 all over 15. Whew! Some heavy-duty stuff. All right, moral of the story. You're going to have to mix in some of your knowledge off of that identity sheet. I am going to leave one for the reserve teacher in 2 spots. One on the front desk and then one over on my, my actual teaching desk. And if the sub wants to make some copies for you guys, that'd be okay with me. All right, next one. What if it's cosine of 2, and that's going to be an angle, right? That's kind of like cosine of 2 theta. Again, that's right off your sheet. And you can look up what cosine of 2 theta is. If I look it on the sheet here, I got cosine of 2 theta is cosine squared x minus sine squared x. And I just got to figure out those angles. All right, so I got to figure out that angle right there. And this right here helps me to figure out an angle. All right, so there's some tips on, I know this is heavy-duty stuff, but that's your job right now today, is to try to take this one step further. We'll look through the homework together in a sec. All right, so next is a topic called solving equations. What's different about this is I am just trying to find x. And sometimes they're easy, like this first one is fairly easy. You've seen something just like this a bajillion times. Notice it does not have any inverse in it. It just wants me to figure out x. Well, x is the angle. That's where the angle goes, right? So this is just like those problems from a couple tests ago, where I say cosine of some angle. All students take calc. All right, I'm going to ask you to pause for a second and everybody figure this one out. Should be a piece of cake. You're going to get 2 answers. Okay, back from the pause, and here's how you should have done this one. Cosine's positive. That means it can't be here, can't be here. This is not an inverse cosine question. If it was, I would limit it to only this zone here, but it is not an inverse cosine question. So I will have two answers. One goes here, and that's going to be adjacent over hypotenuse. The adjacent side is √3, hypotenuse side is 2. That's a 1. That means, oh, this is a 30-degree angle, also known as a pi over 6. So one of my answers is x equals pi over 6. My other answer is down here. And if I know this is pi over 6, then this is a whole bunch of pi over 6s. How many pi over 6s? Not 12 pi over 6, but one less than that. 11 pi over 6. All right. Now, notice this didn't put any restriction that it had to be only angles between 0 and 2 pi. I just want to throw this in at this point, that since they didn't say to only limit this to 2 answers, you get there's actually infinite answers. I could just keep adding 2 pi to these. So I say plus 2 pi k, where k can be any number. That means you can add multiples of 2 pi. So to be safe, if they don't say to limit your answer to only 2 answers, or the answers between 0 and 2 pi, then you should say all solutions, which adds 2 pi k to both of these. So there's your answer for that one. Again, this extra little kicker is just saying, since there's no restriction on how many answers you give, the rest of the answers are found by just adding multiples of 2 pi. Okay, so that's a way to find all solutions. Now this last one I want to talk through with you is cosine of 2x equals √3 over 2. Well, we just figured out if this had just been x, this was just x, we figured out the answers. And x was pi over 6 plus 2 pi k. And the other answer was this one, x equals 11 pi over 6 plus 2 pi k. And now they're asking me to find cosine of 2x. X isn't x anymore. X is 2x. So I'm going to now solve this by dividing everything by 2. Do you get the difference? Instead of just x equals this, it's 2x equals this. 2x equals this, and 2x equals that. So how do I fix it? I divide everything by 2, or even easier, multiply everything by 1/2. Multiply this by 1/2, this by 1/2, and this piece also has to be multiplied by 1/2. And for this answer over here, I'll do it in different color, multiply everything by 1/2. And then this cancels, and x equals pi over 6 times 2 is 12, plus the 2 pi k, the 2 and the 1/2 cancel, and it's just pi k. And then this other one, which is right here, simplifies down to x equals 11 pi over 12, plus these 2's cancel, pi k. All right. That's what you do if you have a 2x, is you solve it just like you did when you had the x, but then you replace your x with a 2x, and then you multiply everything by 1/2. All right, let's look at your homework for today. This is going to be out of day 2, and so here's day 2. I know I had you guys skip these before, but I'd like you to do all of this first page. And again, these sides aren't something you're used to, but it's okay. You don't need the angle. You just need to find sine of the little triangle that you draw. So for this one, it would be inverse. It's an inverse question, and I'd start with that. Cotangent of some angle is √5 over 1. Now, wait a minute. It's cotangent. I told you guys whenever you had one of those sister functions that you should object and say, I'm not going to do cotangent. I'm going to do its sister function. The sister function for cotangent is tangent of the angle is, and then you got to flip it, 1 over root 5. Now I draw my little picture. And tangent, 1 minute each. Tangent of this angle is positive. All students take calc. And if tangent is positive, that means it's got to either be here or here. Can't be here, can't be here. And then since this was an inverse question, then there's limits on tangent. Tangent's only allowed, remember tangent and cotangent are sister functions, so I'm using the tangent rules. So tangent's only allowed in here and here, and it's nothing goes there. That's no man's land. So that means I have to draw my triangle in here, and tangent, TOA, opposite over adjacent, and now I can figure out this side. Square root of 5 plus 1 squared is 1 square root of 6. Okay, and then, now that I got the triangle drawn, you don't freak out that you don't know the angle. You don't care. You want sine of that angle. Okay, so sine in this triangle is opposite over hypotenuse, 1 over root 6. All right, so there's a start. Okay, on this one you'd say inverse cosecant, which is like cosecant of the angle equals negative 3 over 1. Oh, can't do cosecant, so you switch to sine of the angle equals, flip it, 1 over negative 3. And then you start the problem from there. Remember, you've got the rules of inverses, so there's certain places that inverse sine is allowed. Can't be here, can't be here. And it's positive. No, it's negative, so it can't be here. So you must be answering it down here. All right, so that whole page is assigned, and I help you with the first couple. Then this challenge page is not assigned. Then on to this page. All of this page is also assigned. Notice it's got sides of x. I would always put those as x over 1. That way you got two sides. One side is x, the other side is 1. Okay? And I think we're going to have you, this one and this one are not good, but you can do that one. All right, and this one. Also do that one. And that's it. These are, you can skip both of these. That's all I got for you for today. Have a great day.